Welcome to Naughty Notes. Today's lesson is the line graph. Now we're going to make 3 different line graphs together, and then you can answer some easy squeezy Canvas questions. So some of this will be familiar. Looks a lot like, well, linear equations, because it is. But let's get to it. We're going to look at 3 different types. The first one is going to be a discrete. Now, I made up this exercise for you. Imagine that you've got 12 vintage records. That's true, the old vinyl ones. Maybe you got the Beatles collection. And you're going to sell them because your parents are having a yard sale. You know you're going to get 20 bucks each for these. But you know, your time is way too important. So you hire your little brother for the afternoon. And you say, tell you what, little bro, you sit there. I'll give you $5, sit there this afternoon, and I'll give you another 50 cents for every one you sell. All right. Well, little brothers work cheap, so let's get that out of there. That's the premise. So let's see if I want you to take your straight edge. Now, when I say a straight edge, it could be a ruler, doesn't have to have marks on it. Now, maybe you want marks because I want you to draw a horizontal like that. Oops. Bad simulation there. And I want 12 divisions because I can sell, or my little brother will sell, anywhere from 0 to 12. Now, I've only numbered every other one. I think you can figure out that the ones in between are the odd ones. But just space it. You can estimate this, because remember, we're just drawing a picture. I really want you to be able to draw a picture. Okay? Now, this is going to represent our, you guys remember Algebra 1. This is going to be your independent variable, your input variable. Now, I want you to take your ruler and I want you to square it up because you're just drawing a picture. And so you don't need graph paper, but you're going to draw it up like that. And then you're going to put in your vertical. And, I gave it away. We're going to go to a scale of 11. Why 11? Well, that's the most money you could possibly be spending on this operation. You're going to give your brother $5. He sells all 12 records. That's another $6. So that's 11. Now, if you're using graph paper, you might be kind of stuck in making it look a certain way, but I want you to notice this. See, these are rectangular coordinates. Now, the scale on the left, and this interval has to be consistent, but it doesn't have to match the horizontal interval. That's the whole idea of rectangular coordinates versus square coordinates. So maybe your paper looks more like this. Maybe it's a little more in the portrait style. But my video, this is more in landscape, so I'm just going to draw mine like that. Okay? And again, we're going to draw. So what I want you to do is take that ruler of yours and just slide it over. Draw lines, draw lines, draw lines. Draw in all your verticals. Whoa! Not that one, like that. All right? And you got that. Well, how did I build this? Then we're going to spin this thing around and turn your, I guess not that way. We're going to turn this thing horizontal. Take your straight edge horizontal and line it up, and let's just draw a grid. So just line it up horizontal and pass through and make yourself a little grid like that. I know you can do that. So it looks like that. Well, that's close enough. Now, wrong thing. Over here in the left column, this is going to be money. So that's going to be the output variable. And now we're almost ready to plot it. Now in class, I would pause, wait for you to do all this stuff. Say, hey, everybody ready? Ready. Send me a little zoom. Give me a nod and zoom. I can never see you, so you send me something in the chat box. Say, yeah, Mr. Branch, let's go. So we're going to plot these values. Now watch, this is the interesting part. I'm going to say, what if your brother sells 0? It's not his fault. It's raining. Nobody comes out. Or maybe it's really nice for him. Maybe he's a really lousy salesman. Doesn't matter. He sells nothing. You still agreed to give him $5. After all, his time is worth something. Exactly $5, because that's what he was willing to sell it for. Now, you all know where this is going. He sells one, he's going to get that $5 and 50 cents. He sells two, he's going to get the $5 and another $1. Oh yeah, well I can see this. Every one you're going to add 50 cents. So go ahead and add 50 cents. Just like that. You're going to put a little mark just like that. Nice graph. 10 records, $10. I like that. Now, I don't know how likely this is, because that means the very last person has to want the exactly last record. It's always hard to sell the last ones. But you didn't tell your little brother that. Now, the question comes in. Well, do I connect the dots? And I would normally pause for dramatic effect, but your answer is no. You do not connect the dots. Why not? Because this is a discrete line graph. Your brother can sell 8 of your records. He can sell 9 of your records, but he is not capable of selling 8.13627 of your records, because there's an infinite number of values between 8 and 9. But in our example, there's none. You might say we're restricted in the domain on the set of whole numbers. On the set of whole numbers less than and including 12. So we would actually write it that way in the set notation. Remember, with the curvy braces and all? Now, of course, if we wanted to write the range, we'd have to actually list them all. X, no comma needed at the end. And we would list every possible value. Those are all the possible payouts that your little brother's got coming. And that's a graph. That is your discrete line graph. So again, I do look forward to you sending me these 3 graphs. You know, if you have graph paper, I'm not even sure it helped. I think this would look better on blank paper. So you can make your own rectangular coordinates. You know, personally, I would have probably held the paper in portrait style and make it, I would probably steepen this up and it would look nice. But that's one. And you know, we can't talk about discrete without talking about continuous. So I thought we'd use an example from our neighborhood, and that's, when I say our neighborhood, Anchorage, Alaska. We have a lot of light airplanes, and hey, that looks like a Cessna 172. And I guess that's what I'm thinking. Most ubiquitous, love that word, ubiquitous airplanes in the training field. So, you know, we're going to do the same thing. We're going to graph fuel remaining. Now, I'm going to put time on the horizontal axis, but this is how I'm going to do it. I'm going to draw a segment with my Sammy straight edge. And then, you know, 0 through 8. Now, 8 is a power of 2. So that's really easy. I can kind of cite the midpoint of that. Just a little hint. Now, I can probably cite those other 2 midpoints. And then all the midpoints. And there you go. You've got your time in hours from 0 through 8. Looking good. So go ahead and take your Sammy straight edge and let's do this. Let's line it up and let's draw the vertical axis. Now, in the same way, you're going to do it by H in increments, well, 8 little segments, but we're counting by 5s, 5, 10, 15, 20, 25, 30, 35, 40. Why? Well, because, well, I guess in your standard 172, if you checked your pilot operating handbook, you'd say 40 gallons of usable fuel. You know, we don't have the long range tanks. We got those standard ones in our hypothetical aircraft. Same thing as before. We're going to draw the grid. Slide them over and draw those verticals. And we're going to take them and we're going to draw those horizontals, just like that. All right? And there you go. We've got a graph. Get this out of the way. Now, all of a sudden, our domain and range are going to be continuous because your fuel is just burning a little bit at a time. It's going to trickle out a little bit at a time. So how are we going to graph it? Well, we're going to start with 40 gallons because that's the fuel I got. Let's see if I grab that tool. I still got my dot. So we start here. I'm going to look at let's look at 8 gallons an hour. That's 75% power. Well, 8 gallons, this is 5, 6, 7, 8. It's about there. I'm going to go through another 8 gallons. And that's going to be about there. Well, heck, why don't I just go down to the bottom? Hey guys, what's 8 times 5? And you'd say 40. And right there, I'd say, heavens to murgatroyds, if we make it all the way down to there, we're out of gas. And I mean, that's it. That's all we got. So, can you take your straight edge? And that is a continuous function. Because not only are the integral values legitimate, but all the values in between. Now, maybe you're going to go domain and range. Well, the way I did this, and it's a little funny, but I'm going to say that the domain is between 0 and 5. And I'm going to call the variable t, tango. And in this example, I'll say, well, gosh, I guess the range here, F for fuel, or maybe G for gallons, between 0 and 40 inclusive. So that's what we got here. A little bit of throwback, retro, back to your Algebra 1 days. Let's get this out of the way. Well, maybe put that up there. And I should perhaps color that magenta to show that that's the function that we're working with right there. That's at the 75% power level. How about if we're burning at 65% power? Yeah, we'll go slower, but we can burn longer. So we're making this chart, and we're going to say, golly, we're going to go down 7 gallons, and then 7 more gallons, which would be 14 burned. Then 7 times 3 is 21, so we're going to burn 21 gallons up to that point. And we can keep going all the way down there. When we get down 7 times 5, 35. We have 5 gallons remaining. Hey, that's kind of cool. So let's go ahead and draw this graph. And it looks a lot like that. Hey, that's sweet. So there you go. That's my curve. We'll call it a curve. I mean, a line is a curve. So that is our continuous line graph for 2 different burn rates. How would we use it? You know, pilots actually use this stuff. I mean, you can look at it and say, I mean, you just glance at this. You don't need, I mean, it doesn't mean you can't do the calculation. It means you don't have time to do it. I'm glancing at this and I would eyeball this and say, golly, after 3 hours, oh shoot, even if I'm burning, I still got half a tank, nearly half a tank, even at, well, actually a little less than half a tank down here, but I still got more than 15 gallons, even at the higher power setting. Maybe I'm looking at it this way. Hey, when am I going to get down to a quarter tank, 10 gallons? Well, shoot, according to this, well, a little under 4 hours or a little over 4 hours, depending on my power setting. Maybe that's how I'm going to use this, because I can get a feel for the data just at a glance. That's what charts are for. I mean, otherwise we just walk around with calculators all the time, you know, in our pockets and talk to people. Oh wait, we already do that. Yeah. Oh, all right, we'll scratch that. But us old school pilots, we still fly with these things. Trust me. And you need to understand it to pass your written anyway. So we've looked at discrete. Then we've looked at continuous line graph. There's one more, and it's called the broken. It is the broken line graph. And okay, I'll admit I took this example a bit from the book and kind of changed it a little bit. Yeah, I'm not terribly proud of it, but it's what I got. So we're going to draw horizontal again with my straight edge. You could do the same trick, like cut it in half, 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 because we're going 8 hours. So we're planning on an outing. You got all day to ride. What else would you rather be doing than riding your bicycle for 8 hours a day? Maybe you're training for that, for a Lava Man triathlon. Then you're going to take your straight edge and you're going to turn it perpendicular. And here's a little trick. You see the little gradients in there like this? If you line that up, see, that's a good way to draw a perpendicular line. If you're in my geometry class, you're going to need to swing a compass and construct. But we're just drawing here. We're just drawing an axis. And maybe you want to work on this back side. So I'm going to draw the y-axis. Now, this is going to be a funny little graph. And the y-axis is going to represent miles away from home. So the input variable, or the independent variable, is going to be time. Then how far from home am I? So we're going to say you drove to a spot on the Seward Highway, and you're going to ride down the Seward Highway like all those people that, with the wind. I mean, those poor folks. When you see them, please give them room on this highway. And I'm going to draw all these vertical lines in like that. And then I'm going to rotate this thing, and I'm going to draw all of these, and I'm just going to get a grid just like we did before. Come on, easy squeezy. Get that ruler out of there. This time we're going to do something different. We're going to say, hey, let's suppose you do this. Let's suppose you said, I'm going to ride for 2 hours and I'm going to cover, oops, I missed. Sorry about that. For 2 hours and I am going to cover 30 miles. 30 miles right there. Now, what you know so far is that you've gone 30 miles, you're averaging on this, and it's taken you 2 hours. So this is representing an average speed, let's pick the appropriate color here, of 15 miles per hour. How did I get that? You say, well, I took 30. You're traveling 30 miles from your car, and it took you 2 hours to do it. So during this interval, you're cruising along at 15 miles an hour. But then you change the slope. You change your speed. You do this. Maybe you hit the town of Girdwood, and you're pedaling into Girdwood, and you're on your cool down. Heck, here you can take 2 hours, and you're only going 10 miles. 10 divided by 2. During this interval, you're going a paltry 5 miles per hour. Gosh, well, I mean, you could jog that fast. I mean, you could run faster. So you must be, I don't know what you're doing, but you're dogging it a little bit. You're resting. Then, of course, you end up at the bake shop. Who doesn't? You're at the bake shop, what do? You have soup. So you're stopping there, and you're making no progress. You're not moving at all. I mean, maybe you're going up and down to get more bowls of soup, but that's what we do in Girdwood. And then you're saying, all right, man, I got to get back to the car. And I've already burned up 5 hours. I'm just going to hightail it back, all the way back like that. Now, 15 miles an hour, this interval, 5 miles an hour, 0. Here, you're standing still. How about here? You're going to cover 40 miles. Let's write this out like this. Let's put it proper like this. 40 miles. And you're going to do this in an interval of 3 hours. So if you want to turn that into miles per hour, 3 goes into 40 exactly 3 times, or 13 times with a remainder of 1. So that would be 13 1/3 miles per hour. That would be your average speed here. Now, I don't know if that's a good example. I'm personally, I haven't used a lot of these, but that'll get you through the quiz. How about some trick questions like how far did you ride total? Well, you rode 80 miles. Because look, it took you 1, 2, 3, 4 hours to get 40 miles away and 3 hours to get 40 miles back. So this rider had a good day, 80 miles. Maybe it was on the mountain bike, maybe it was on a road bike. I don't know. I don't know what you guys want to ride when you're on that Seward Highway. But, well, that's going to conclude our brief look at our three different graphs: broken line, continuous, and discrete. So I hope you find this helpful, and you've got a quiz in Canvas. And if you're not in my class, thanks for joining us. But for everybody, thank you for watching Nani Notes.